Invisible students?
Yes, ma'am.
Okay, fine. So as of now, you have seen that we were discussing software life cycle models, and we have discussed different life cycle models like we have discussed the classical waterfall model and then iterative waterfall model, then prototyping model, then evolutionary model. And we have discussed there were what were the advantages of those models and what are the disadvantages due to which another type of models came. Okay? So in this way, we are learning everything phase by phase. That is, first we have learned classical waterfall model. What is it? What are the advantages and disadvantages of it? And next, iterative waterfall model, its advantages, disadvantages, prototyping model, and evolutionary model we have learned. And the last type of model is spiral model. But there is another type of model that is RAD, which is called Application Development, but that is not included in your syllabus, I guess. So that's why I think I will be completing spiral model and this chapter will be completed. Okay. So see here, spiral model. So today we will be discussing about spiral model. So what is a spiral model? Basically a spiral. In this way, it is spirally hanging. So that's why it is called. It was proposed by Waterfall in 1988, and each loop is each loop of that spiral represents a phase of the software process. Okay, so the innermost loop might be concerned with the system feasibility, the next loop with system requirement definition, the next one with system design, and so on. Okay, so see here, basically the exact number of loops. So in spiral model, there are a number of loops. Okay, there are a number of loops present, and see here we have divided the model into four quadrants. First one is for determining objectives, then identifying and resolve the risks that are there in the project, then develop next level of product, and finally the customer evaluation. And if the customer evaluation is good, then we will stop the product. Otherwise, again, we will continue. So in this way, it is see spirally hung over this. So that's why it is called spiral model. So here the exact number of loops is loops of the spiral is not fixed, okay, and can vary from project to project. So see here, this is a loop kind of structure, and see here it is forming like from here it is starting and it is rotating up to this. Okay, so in some project you can find that this rotation, that is if you consider this phase, that means it is taking 1, 2, 3, 4 phases to develop. But in some projects you will see that only not in some projects there are 5 or more than 5 phases. Also in 2 phases it has got completed. So it totally depends on the on project to project. Okay. So each loop of the spiral model is called phase of the software process. So see here, all these loops are basically phase of the software process. Okay. So the actually it can be seen that this model is much more flexible compared to other models, since the exact number of phases through which the product is developed is not fixed. So that's why whenever you are having a small product, you can take 2 loops. Whenever you are having a big product, then you can need not here I have given 4 loops, but it may happen that you need 5 to 6 loops. Okay, so over each loop, one or more features of the product are elaborated and analyzed, and the risks at that point of time are identified and are resolved through prototype. Based on this, the identified features are implemented. So see, that's why we have said that the innermost loop might be concerned with the system feasibility, and the next type is linked with system examination, the next one with system design, and so on. The whole process continues. So there is no fixed phases in this model. The phases shown in the figure are just examples. When we actually use the spiral model is when the team must decide how to structure the project into phases. So if you are given already some structure and based on the structure, you are dividing that structure into different modules, then we can say that spiral model is actually used there. Okay? Also, start with first using some generic model like add extra phases. It is for specific projects or when problems are identified during the project, and each in the spiral is split into 4 quadrants. So every time heading the loops into 4 quadrants in spiral model. But these loops can vary. Okay, these are the quadrant students. Okay, and loops are this one. Okay, so in this way it can vary. Okay, so see, this is first one is determination of objectives. That is, we can determine the objectives and identify alternative solutions. Next is identify and resolve risks. So this is the phase number 2. And in this phase, we are actually identifying the risks that are present in the project and we are resolving those risks. Because in every project, you will find that there is some or somehow there are risks present, even if the risk is small in size, that is not that much risky project. So, but also you will see that risks are part and parcel of every project. So, next quadrant, in the third quadrant, you can see that in the third phase, it is given develop next level of the product. So here you are developing the next level of the product, and in the fourth case, in the fourth quadrant, you can see that here customer evaluation of prototype is given. That is, here they are giving the review and planning for the next phase. So first, see here. So see here, this is the first quadrant. Okay, so why do we say the first quadrant? That is, why do objective of setting the first quadrant is like identify objectives of the phase. Okay, so see here in the first quadrant it is written like, see, objectives. Okay, determination of objectives. Any kind, whenever we are, second is the examine the risks associated with these objectives. So what are the risks generally that a project undergoes? See, basically a risk is essentially an adverse circumstance that might hamper the successful completion of a software project. So this is basically a risk, that is, it is hampering the successful completion of the project. So you can take an example like the risk involved in accessing data from a remote database can be that the data access rate might be too slow. So if the data access rate is slow, then we can say that this is a kind of risk. So this risk can be resolved by building a prototype of the data access subsystem and experimenting with exact access rate. So basically the spiral model provides direct support for coping up with risks by providing the scope to build a prototype at every phase of software development. So see here, whenever you have seen that in every step you have seen, that is whenever you are growing, you are when you are in class 1, okay, now you are in college 3rd year. So every time you have grown from every phases and you have seen all the phases and you have seen what are the risks that are there in every phase, okay, throughout your development process. So also now you are a fully grown adult student. So you know that what are the risks that may come when you are a child, that is when you are a kid, okay, and also when you are like teenage, you know the what are the risks that may come when your age is in teenage. Now you are completely young, but you know everything because you have handled those things. So similarly, risks also happen in software when it's software development in every phases. So that's why we need to identify those risks and we need to resolve those risks accordingly. You see here, and also next is finding alternate solutions that are possible. Next, what is risk assessment and reduction? So second quadrant, it is given, the second quadrant, it is given that identify and resolve risk. Okay? identify and resolve risk. So we know that each phase in this model is split into four sectors. Okay. So in the first quadrant, we have seen that some features of the product are identified based on the severity of the risk and how crucial it is to the overall product development. And also implementation of the identified features forms the objective of the phase. So basically the objectives are investigated, elaborated and analyzed, and based on this, the risks involved in meeting the phases objective are identified. So here also alternative solutions are also possible for the phase under consideration that are under the consideration proposed. Okay. During the second quadrant, see here in this second quadrant, what happens? Alternate solutions are evaluated to select the best possible solutions. So we are providing some alternate solution, and from not only one solution, there can be number of solutions, and from those solutions, we are actually selecting the best possible solution. So to be able to do this, the solutions are evaluated by developing an appropriate prototype. Okay, so we are developing an appropriate prototype here. So activities during the third quadrant. So this is about the second quadrant. So basically in this second quadrant, three steps we are following. That is, for each identified project risk a detailed analysis we are carrying out, and there are steps that are taken to reduce the risk. And for example, if a risk that the if there is a risk that the requirements are inappropriate, a prototype system may be developed. So whenever we are analyzing that in our system, there is a kind of risk present, and you can analyze anything depending on your experience. So if you are having any experience and if you see that at this phase of the project, you may have a risk. So in that case, what you will do is you will develop a prototype system which may or demo of that system, so that you can understand that while developing the system, this kind of risks may come and we can resolve this kind of risk by this process. Next is, see here in case of spiral model, the next phase is the third quadrant, in which we are actually developing and validating the next level of the product. So see here, at the end of the third iteration, the identified features have been implemented and the next version of the product is available. Basically, the activities during the fourth quadrant concern reviewing the results of the stages traversed so far. So in the next quadrant, it is about review and planning. So basically review the results achieved so far with customer and plan the next iteration around the span. Whenever you are, this is the most important phase, that is review and planning, because if everything looks like it's going perfect, but unless you are getting any review or feedback from the customer, you do not you from your perspective you will find it out that everything is fine. But whenever customer is evaluating or customer is reviewing your product, then only we'll be able to understand that whether it is working fine or not. Because we know that everything works two ways. Okay, if you are doing in one way, your project is in one way direction, then you will never be able to understand that your project is working fine or not, will work fine or not, and whether the customer is going to accept your project or not. But whenever you are giving any review or feedback, then only you will be able to understand, yes, I have this faults in my project, and that faults can be resolved by using some kind of strategies. And it is called planning. So those strategies are actually developed by having a open forum meeting, and in that meeting actually they discusses those problems and sort out the solutions. Okay? So in this way, actually the whole process is carried out. So if you consider our example also, you will see that we are having a feedback system in our college. So see here, I am taking class of software engineering and I am giving 100% effort to make you understand. And I am assuming that I am letting you understand every concept. But as because if there is only one way communication, because I am taking class, I am teaching, but no, if no one responds in my class, then I will think that yes, everyone is studying and everyone has understood all the concepts. Unless that feedback sheet is provided to me. Whenever I will be given the feedback sheet, I will check that yes, when that students are remaining silent because they are not understanding anything. But when in that means if someone is not saying anything, that means he is not understanding. So from that's why feedback system is important. Similarly, in case of software development, we also use review plans and feedback systems so that whatever we have developed, so that the developer can understand that it is not matching with the client. Is it matching with the client's requests or not? So in this way, it will follow the procedure. So see here, to make the model more efficient, basically to make the software model more efficient, the different features of the product that can be developed simultaneously through parallel cycles can also be identified. Okay, so see here with each iteration around the spiral, basically progressively more complete version of the software gets built. As long as the it follows iteration, it develops more complete or upgraded version of the software. So with actually, we can say that the radius of the spiral at any point would represent the cost incurred of the project so far, and the angular dimension would represent the progress made so far in the current phase. So it is the radius. Okay, right? This is the radius from center. This is the radius. Okay, up to circumference, it is called radius of a circle. So here, actually, it is forming a circle. So that's why you can see that from this, that the radius of the spiral at any point would represent the cost incurred in the project. So basically, it is representing the cost. The radius is representing the cost. That is, whenever this loop will continue, here we are having 4 loops, but if the looping is up to 8 or 10 loops, then the radius will also increase and the cost will also increase accordingly. Okay, and the angular dimension would represent the progress made so far in the current phase. So in spiral model of development, the project manager dynamically determines the number of phases as the project progresses. So that's why before starting of the project, you are not having any idea that how much loops it will take, because it is taken, the decision is taken dynamically, because based on the customer evaluation or based on the risks that are present in that second phase or based on the development of the next product, actually the product manager is defining the number of phases that the project will undergo. So therefore, while using this model, the project manager needs to play a very crucial role in tuning the spiral model of the project. So in this case, the project manager is playing a very important. This is about the spiral model, and there are, as we have seen, that in every model there are certain disadvantages and advantages. So also spiral model is also having lots and lots of advantages and disadvantages. So there are a few disadvantages of the spiral model that restrict its use to certain projects only. Okay, so you cannot use spiral model in every project. It is only restricted to some of the projects. And to whom actually it is restricting? Actually, to the developers of a project, the spiral model usually appears to as a complex model to follow, since it is risk driven and it is more complicated than the other models. So see here, actually we have seen many other models, but those models are quite simple. But spiral model is comparatively complex. So that's why many of the developers do not find it comfortable to use spiral model, because of its appearance. It appears too much complex. So that's why it requires knowledgeable staff also. So if you are having a knowledgeable project manager, then only you can use spiral model. And if not, then it is not a good idea to use spiral model, because by experience only you can understand that this kind of risks can be present at this phase, and those risks can be resolved by these strategies. And that's why it requires some knowledgeable staff. And also it is not very suitable for development of a product as outsourced projects, since the product risks need to be continually assessed as it is developed. So at every time you can see that we are actually checking that whether any risk is present at any phase or not. So that's why it is very difficult for any product that is for using this model for outsource projects. Okay, so for certain categories of projects, the advantages of spiral model can outweigh their disadvantages. Like in some more, in some product development, you will see that spiral model is having so many advantages that disadvantages you can negate. Okay, so for projects having many unknown risks that might show up as the development process, the spiral model would be the most appropriate development. So in this, that's why you can follow spiral model. So actually, it is much more powerful than the prototyping model, which requires that all the risks in the project should be known at the start of the project, and all risks are resolved before the product or development starts. That means whenever you are starting anything, you don't know what kind of risks you may face, because see, if you consider your life cycle, as of now you are in third year, and up to third year, from the day which in which you are born, you have seen what are the risks and what are the problems you can face in your life. So that is fine, but problems comes dynamically in your life. You cannot say that at this age I will definitely have a problem. You can estimate that this kind of problems generally occurs or generally happens in this age. Like when you know that whenever you will be in fourth year, you will be having classes as well as you will be having placements also. So now you are having only classes, but you are not attending regularly. And whenever you will be in the fourth year, you will see that you have to attend classes, you have to attend placements, and there are many more things, many more competitions which are going on. You have to attend those things also. So you have an idea about it, but you do not know exactly that whether you need to attend all the classes or not, how many subjects will be there or not. So those are rough calculations, and those actually you can not know exactly. So that's why for those kind of things, spiral model in case of software development, like whenever any company is developing any software, those kind of things or assumptions are required. And if that actually is that assumption is exact assumption and it is correct, then really we can use spiral model. Otherwise, it is not a good idea to use spiral model. So am I clear, students? Am I clear?
Yes, ma'am. Yes, ma'am.
Pratik, is it clear? Pratik Pradhan,
Yes, ma'am. Yes, ma'am.
is it clear?
Yes, ma'am. Yes.
Okay. Spiral model as a meta model. Now remember this thing, spiral model is used as, or the another name of spiral model is meta model. Okay. Remember this term. Whenever in your question paper comes, which of the following model is also known as meta model, you need to take spiral model. Suppose four options are given: waterfall model, iterative waterfall model, prototyping model, and spiral model. Then you are going to look at spiral model. Okay, so basically, uh, spiral model subsumes all the discussed models. That is, a single loop spiral model represents waterfall model, uses an evolutionary approach. Okay, iterations through the spiral model are evolutionary levels and enables understanding and reacting to risks during each phase, each iteration along the spiral. So in spiral model, you will see that waterfall model is there, evolutionary model is there, iterative waterfall model is also there, and prototyping model is also there. So all the actually it is a collection of all the models. So here in this diagram, you can see that It is following waterfall model strategy because all the steps are there and we are following the sequence in this way. It is also having iterative waterfall model strategy also because once you are done with one step and on the next step, if you are committing any kind of mistake, you can undo and you can go to the previous step. Okay. Similarly, it is having a idea of evolutionary model because you can see from code we are developing and we are at each phase we are gaining some more modules. So that's why evolution is also happening, and also it is having a prototyping model functionality also because there you are developing a prototype and it is showing to the customer and they are giving some reviews, and based on the reviews we are actually deciding whether to accept the model or to reject the meta model. So basically, the spiral model can be viewed as a meta model since it subsumes all the discussed models that we have seen, that we have learned. So here, so this enables that this enables the developer to understand and resolve the risks at each level. So that's why the spiral model uses different type of models, that is typing model, waterfall models, prototyping model, waterfall model, then iterative waterfall model, and also the evolutionary models, the systematic stepwise approach. Okay. So see here, it uses prototyping model as a risk reduction mechanism. So actually, whenever it is seen that there is in the risk in the project, it is using prototyping model and retaining all the stepwise approach of the waterfall model. So comparison of different life cycle models. So we've seen that we have understood and we have discussed all. Now, why? Let's just compare all the life cycle models. Okay, so we have seen this chapter. We have discussed 5 types of life cycle models, and we are going to compare each and every life cycle model and check which one to follow when, which one to follow and when. So see here, iterative waterfall model, actually it is most widely used model and it is suitable only for well understood problems. So if your problems are very simple and easy to understand, in that case we will be using iterative waterfall model. Okay. Next is prototyping model is suitable for projects not well understood. So whenever the projects are not clearly defined by the client or the client is having confusion or it is client is unable to explain the requirements properly, in that case you can use prototyping model because whenever you will be building any prototype, whenever the client will see the prototype and it will, then the client will understand, yes, this is not the thing which I want, I'm demanding. So in this way, you can see that the risks are reduced. So that's why prototyping model is used for those projects which are not well understood and user requirements. And there can be 2 types of things, that is either the user requirements are not clear or technical aspects are fake. So in these 2 cases, you can use the prototyping model. Next is evolutionary model. So basically, evolutionary model is suitable for large problems. Whenever you are having a large problem, in that case, you can use evolutionary model. First, you can make a code, and based on that core module, you will be adding some more modules the later stages. So that's why it can be decomposed into a set of modules that can be implemented, and incremental delivery of the system is acceptable to the customer. So this is about evolutionary model, and the last one is the spiral model. So spiral model is basically suitable for development of typically challenging software products that are subject to several types of risks. So whenever you are having any very risky project and which is technically challenging also, in those cases, you will be using the spiral model. So with this topic, we are coming to an end of this chapter and we have discussed the different life cycle models. So just let's summarize the overall chapter. But before that, I would like to ask Students, do you have any queries regarding this chapter? Any query?
No, ma'am.
No? Any
No,
other
ma'am.
student?
No.
Okay. So see, we have seen, first thing is we have seen that during the development of any software product, adherence to a suitable process model may become, has become universal, and adoption of a suitable life cycle model is now accepted as a primary necessity for successful completion of projects. Okay, so for whenever we are actually developing any project, so actually we are discussing the central ideas behind some important process models. So good software development organizations actually carefully they are and elaborately document the precise process models they follow, and typically include the following include several documents in an order. That is, first they identify which is identification of the different phases. In the second, it is the identification of the different activities in each phase and the order in which they are carried out. Then the phase entry and exit criteria of for different phases. The fourth one is the methodology followed to carry out the different activities. So see here, the principle of detecting errors as close to their point of introduction as possible is known as phase containment of errors. So we have discussed about phase containment of errors, and in questions, in exam questions asked like what do you mean by phase containment of errors? So you need to say that the principle of detecting errors as close to their point of introduction as possible is known as phase containment of errors. And phase containment minimizes the cost to be fixed errors. And here also we have discussed 5 important life cycle models, that is classical waterfall model, iterative waterfall model, prototyping model, evolutionary model, and spiral model. So the classical waterfall model can be considered as the basic model, and all other life cycle models are actually built from this model. So iterative waterfall model is the most widely used life cycle model so far, and different life cycle models have their own advantages and disadvantages also. So therefore an appropriate life cycle model should be chosen for the problem which you are given. So after in the first case, we can do it. So after choosing a basic life cycle model, software development organizations actually used to follow the standard life cycle models according to their needs. So even though an organization may follow whichever life cycle model is appropriate for project, the final document should reflect as if the product was developed using the classical waterfall model. Whatever they are actually following, they are reflecting the classical waterfall model as in the document. So So that's why this makes it easier for the maintainers to understand the product requirements. So this actually we come to the end of this chapter. So one chapter of software engineering, that is software lifecycle model, has been completed. So if you are having any doubt, please let me know, because in the next class I will be starting another chapter, that is software project management. So the chapter will be software project management and how we actually managing any project, and actually that concept of the chapter is based on this chapter, on this present chapter, which I have completed today. So that's why if you are having any query, you can ask. Feel free to ask. Students, please say if you are having any query. Anyone having any query, students? Don't remain silent. If you are staying silent, that means I would understand that all of you have understood everything.
Yes, ma'am.
So in the next class, that is tomorrow, I am going to start another new chapter. And one more thing, I have given you the assignment, so I am again give you one reminder that 22 is the last date to submit the assignment. All of you should submit the assignment within 22 and in the Google Drive in the CA1 folder. Everyone should submit. Everyone's submission is mandatory. I'm not going to give anyone marks unless that person is submitted the assignment. Don't expect marks from me if you are not submitting the assignment. Okay. And also, so tomorrow you are having class from 10, right? From 10 you are having class. So everyone is attending, will attend to tomorrow's class, right? Because tomorrow is a puja, like Shukarma puja. So students, you will be attending tomorrow's class or not?
No, ma'am. No, ma'am.
All of you?
No, ma'am.
No, ma'am.
So tomorrow you are
No,
not
ma'am.
going to attend, right?
Yes.
Okay, fine. So, okay. I will have a word with your CR and I will let everyone know what to do. Fine, students. So thank you for attending today's class. Now you can leave. Let me download the attendance list first. Downloaded. Now you can leave.